In this lab, we're going to have the students put together an N-phase microinverter system. Now, this is one of three labs that typically when I have a large class, I just run simultaneously. I usually will break up one group into the Solar Edge lab, another one doing the microinverter lab, and then a third group will work on the hybrid lab, the wind turbine hybrid lab. Now, when you unpack the kit for this box, you'll find the small box with all of the bolts and connectors. Then there'll be wires. Each of these wires are labeled for the circuit that they go to. Then there'll be some flash footers. The footer portion is in that small box. Some proprietary N-phase cabling, 3 N-phase microinverters. There's also going to be a junction box in there that will connect to the array, and an N-phase combiner box. We'll talk a little bit more about that later. And then it ends with the AC disconnect. Just as in the string inverter, have the group go ahead and hook up the flash footers and then connect the rails to those flash footers. As indicated in this photo, the inverters are mounted on top of the rails just using a single bolt. They fit in very nicely. You could try and mount them on the back of the panels like we did on the optimizers, but I think you're going to find they're a bit too heavy for that. Use the enclosed wire clips to manage the cables, the proprietary cable from Enphase, as shown here in this picture. Then have the students snap the proprietary cable into the microinverter. There's really only one way it can go, so they can't really mess that up. Then the male and female MC4 connectors from the panels connect into each microinverter. Again, can't really mess it up. Only one microinverter for one solar panel. One end of the N-phase proprietary cable will be pre-terminated. The other end will have line 1, line 2 wires exposed. Go ahead and feed those exposed wires into the junction box and then terminate line 1, line 2, the red and the black, onto the DIN rail as indicated in this picture. On the other side of the DIN rail, you're going ahead and run the line 1, line 2, as well as an equipment grounding wire through the conduit, and then those will be terminated into the N-phase combiner box. The black wire entering into the N-phase combiner need to be fed through the current transformer, the CT, and then terminated up there at the circuit breaker. It should be indicated as line 1. Then the red wire will go outside the current transformer, and it will be terminated at the other pole of that double pole breaker. 2 of the breakers in this picture will not be in your unit. This just kind of demonstrates this combiner box is designed to handle 4 branch circuits coming from the array. We're only going to be dealing with one, so there'll only be the one branch circuit double pole breaker. But the other double pole breaker is there to feed power to the communication system. That's already going to be pre-wired, so the students shouldn't have to mess with that. The Enlighten communication system is built into these combiner box. It's that circuit board that appears up at the top. Again, the student shouldn't have to mess with anything there, but it's there and you can point that out to them. Then also there are additional CTs that can be installed, those blue and white wires. They're designed to connect into those little communication ports in the side of the combiner box, and they run all the way typically to the line 1, line 2 feeds from the electric meter into your service panel. If you've got a more advanced class and you want to focus on that, feel free. The neutral bus bar is at the bottom of this unit. Now this is going to be the first neutral that you're going to have in this wiring system, and that's going to feed from the N-phase combiner box over to the AC disconnect. Then also at the bottom of this unit is the grounding bus bar. You'll be bringing in the equipment ground from the junction box into there, and then you'll be feeding from here to the AC disconnect with a ground as well. The proprietary wire that connects together all the microinverters, one end will be terminated, the other will still have the line 1, line 2 exposed. Feed that into the junction box and then attach to the DIN rail. Then feed on from there to the combiner box. Make sure that the black wire is going through the CT and that the terminations are made on the breaker at the right location. Then at the bottom, you're going to be leaving here with the ground wire as well as the neutral. And also notice line 1, line 2 connect to the bottom of the bus bar. They then feed into the AC disconnect. Make sure everything's connected properly. Remember, the inverter is always the load. So in this case, you'll see the students have actually hooked them up to the wrong end.